Hello everyone. In this video we will see another problem, and that is move zeros, right? And this is two pointers technique. You are given an integer array nums. Your task is to move all zeros to the end of the array while maintaining the relative order of the non-zero elements. Uh, okay. So if we see the input, right? So 0 1 0 3 12, and output is 1 3 12 and then 0. So we just have to move to the zeros to the right. You understand? After all the non-zero elements, we will move all the zeros. This is the thing we need to do, right? Okay. So we will see the program, right? And time and space complexity of this. If we come here, right, we have the main function, nums. These are the numbers, and then we're determining the size of it, and then move zeros is this is not integer or nothing. Okay, this is we are directly calling this function, right? So that is why it is void here, void type of function. Okay, this will not return anything, and then we are printing the array after moving zeros, and then we have something to print. But now we need to go to the move zeros. If we okay, let's copy this program. Come here. Okay. Anyway, so let's copy the numbers. Okay, so we have the nums and num size. You know why we give pointer here, right? Because we are dealing with an array, and integer last non-zero found at 0. Position to place the next non-zero elements. We will see how this works. Why we need to take this and everything, right? The first iteration. Okay, I starts from 0. Num size is 3 5. So if num size I not equals to 0, okay, then we can enter into this loop, if statement. Okay, so we have two for loops, we know. Yeah, this is a for loop, and after finishing this we have another. Okay, so let's see how fast for loop works. So aim of this for loop is move all non-zero elements to the front. Move all non-zero elements to the front. Okay. Okay. So this is not true. Num size 0 in our position 0. First one is 0. So we can't do anything in the first iteration, right? Go for the second iteration. Second iteration, I is 1. 1 is less than 5. Okay. So in one position we have 1. So now this is true, right? So nums last non-zero found at. Okay. So it's assuming that last non-zero found at. That means we have found at last non-zero found at 0. Okay. This value of this is 0. So you don't you make yourself confused that last non-zero found at 0. In 0 position we have 0. How is this possible? This is just a variable to to go for our aim, right? So nums, that means last non-zero founded is 0. So nums 0 is 0, right? Equals nums I is 1. Okay, so here we are in nums last non in nums zeros position we are in zeros position we are providing 1, right? So how the array will be now, right? So the array becomes, I'm just writing it like this, okay, and we will copy this, paste it here. That means this 0 is becoming 1 now. You understand? According to our what we did, we copied 1 in the 0th position's value, right? Okay, now we will increase this 1 by 1. You understand? Okay, let's go for the third iteration. And array, so present array is now this one, right? So let's provide this here, right? Now I is third iteration, right? So I is 2. So here we have 0, right? So we cannot move enter into this if statement. This is 0. Okay, go for the fourth iteration. Fourth iteration I would be 3. So here we have value 3. So this is not 0, we can enter into this loop. The last non-zero founded, its value was 1, right? In the first position we will uh, copy the value of nums I. So I is 3. So in third position's value is also 3. So 3. Okay, so now the array becomes, nums 1 means this one, this value, right? So in this value we are copying 3 now. You understand? This is not 1 anymore. We are copying in this position we are copying the value of this, right? So 3 is coming here. So now, okay, and left last non-zero founded 2. So this is going to be increased. So now we will go to the fifth iteration. Okay, let's go for the fifth iteration. So here 4 0 1 2 3 4. So we have 12 here, not 0. So we can enter into this loop. We had 2, right? Last non-zero founded, its value was 2. So in the second, okay, we didn't change the updated array, right? Anyway, we're just visualizing, okay, you're just simulating the code. So array becomes last non-zero founded 2, nums 3. So the array become like this. Anyway, we didn't finish it yet. So last non-zero founded 2, right? Okay, in the previous array it was 2. So that means 0 1 2. In this position we will copy 12, right? Because I is 4. In fourth position we have value 12. So 0 1 2. In 2th position we will provide 12, right? So 3 and 12. So there is no 0 in our array now. You see, there is no 0, but we finished this for loop. Okay, okay. We will copy this, fill the remaining position with zeros. Okay, so now we have another for loop, first iteration. Okay, so now we will copy, our array is now this, right? We just changed, we removed all the arrays. There is no 0 in the, so in this for loop starts from I equals last non-zero founded. So last non-zero founded was 2, right? So I start, that means I start from 2. Num size is 5. Okay, so nums I, that means nums 2 would be 0, right? uh, uh, let me see, not 2. In fifth iteration we didn't increase it, sorry. Okay, I was thinking something else. So this was 3, I starts from 3, right? Okay, so 3 is less than 5. Yes, this condition is true. So when it's 3, nums 3, 0, 1, 2, 3. So in this 3, we will, you know, uh, assign 0, right? So the array will become, here we will get 0, right? So let's just, here we will get 0. I'm just okay. So if you want, we can write, so the array becomes it's like this. So the array becomes, we can do like this too, right? And then we have another iteration of this, right? Here we have 4. This will increase by 1, right? So in fourth position, nums I would be, in case of 12, we will provide 0 as well, right? So finally 1, 3, 12, 0, 0. This is the array we got, right? So now move zeros is giving us this value, right? Okay, so now we have to print it. You understand? If you want to display in the display these values, then you have to I'm sorry. So let's just take this. Okay, if you want to display in the screen, then this array after moving zeros, uh, okay, print array after moving zeros. So this is, this will come after the print statement. So I start from 0, num size is 5. Okay, the print in nums I. So that's print percentage d nums I. Num size was 0, it will print 1. Then it will take the second iteration. It will take the second iteration. It will be 1. Okay, so 3 will be printed. So this is how third iteration, fourth, fifth iteration. So all the iteration will take place, and the final value will be printed, right? So this is how it works. If you take the time and space complexity of this, right, we will see. Okay, so if we just see the program, right, if we just see the program, we see this for loop goes from 0 to num size. That means it can go 0 to num size, means all of the numbers will be iterated. That means on, right? uh, okay, and last non-zero found that this is going to plus plus. So there is, it's not doing that much. So on should be the times complexity, uh, and if you see the space complexity, right? uh, okay, uh, 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 okay, if you see the space complexity, uh, we took 5 numbers, and we are our input size was 5, and we are also what do you say, we are also returning 5 elements. So I think space complexity also should be on, right? This is my assumption anyway. Let's give it to ChatGPT and ask about time and space complexity. Time complexity, what the code does, you have two separate loops. First loop, num size -1 scans the array once, move all non-zero elements to the front. Second I equal to last non-zero founded num size minus 1 first fills the remaining position with 0 total operations first loop runs n times second loop runs at most n times even though there are two loops they are sequential not nested total time complexity O1 right space complexity extra memory used only a few integer variables last non-zero founded loop by variable no additional array of dynamic memory okay so space complexity would be O1 not On right I thought uh, we we returned 5 elements so space should be no so this doesn't work in this way we got it okay so we didn't occupy any memory we did no additional array or dynamic memory whatever uh, so space complexity would be O1 right constant extra space right so this is an optimal in place solution extra okay so this is how it works thank you for watching we need to focus on time and space complexity and with practice this will all of them will be uh, stuck in our head right our brain will see the patterns and everything but we will have to move on we will have to do them always right